In an effort to address labor shortages and promote American reindustrialization, NVIDIA today announced that the country's top manufacturers, industrial software developers, and robotics companies are utilizing NVIDIA Omniverse technologies to construct new autonomous collaborative robots and state-of-the-art robotic factories. According to Jensen Huang, creator and CEO of NVIDIA, artificial intelligence, AI, is turning factories around the world into intelligent thinking machines that are driving a new industrial revolution. We are constructing physical AI, Omniverse digital twins, and collaborative robots in partnership with America's manufacturing leaders to boost competitiveness, productivity, and resilience throughout the American industrial base. NVIDIA declared that it is adding capabilities for creating and simulating factory digital twins to its mega NVIDIA Omniverse blueprint for simulating robot fleets. The first business to create digital twin software that complies with the mega Omniverse blueprint is Siemens. The Siemens Accelerator platform will incorporate the new industrial technology stack, which is currently undergoing beta testing. It will assist engineers in creating and managing expansive digital twins of factories that combine real-time operational data with lifelike 3D representations. This technological stack, which was created for the AI era, allows for thorough modeling, optimization, and real-time performance monitoring, all of which can aid in the construction of more intelligent and effective factories, goods, and data centers. To make it simple for manufacturers to drag and drop equipment into their digital twins, Fanuc and Foxconn were among the first robot manufacturers to provide 3D OpenUSD-based digital twins of their robots. Huang demonstrated how Foxconn is utilizing the new Omniverse technology to build, simulate, and optimize its new 287 square foot plant in Houston, Texas, for manufacturing NVIDIA AI infrastructure systems during his keynote talk at the NVIDIA GTC in Washington, D.C. In 2025, it was stated that $1.2 trillion would be invested in expanding U.S. production capacity, with semiconductor firms, pharmaceutical companies, and electronics providers leading the charge. In order to power this wave of industrialization, the top corporations in the country are depending on Omniverse libraries and apps from independent software vendors to create robotic factories that use simulation and physical AI to speed up manufacture. To create virtual safety fences for immediate hazardous zone monitoring and real-time quality inspection systems in factories and warehouses, Belden has deployed Accenture's Physical AI Orchestrator, which combines NVIDIA Omniverse libraries, the NVIDIA Metropolis platform, and Accenture's Agentic AI. NVIDIA NIMTM microservices are being used by Caterpillar to drive workflow automation and predict and optimize factory maintenance. NVIDIA QOptiTM software is being used to optimize supply chain performance, and Omniverse is being used to create digital twins of its factories and supply chains for use in advanced manufacturing capabilities like dynamic scheduling and predictive maintenance. Omniverse is being used by Lucid Motors to train AI-driven robotics systems and create digital twins of its factories for real-time planning and optimization. Toyota is building digital twins of its Georgetown, Kentucky factory and investigating intricate automation scenarios using IdealWorks IW.Sim technology, which incorporates features from the Mega Omniverse blueprint. At its facility in Phoenix, Arizona, TSMC is utilizing the NVIDIA Isaac platform to develop robotics for specific activities and Omniverse to speed up fab design and construction in order to greatly increase manufacturing output. Wistron is putting in place a stringent digital testing and validation procedure for the systems it assembles in its Fort Worth, Texas, facility by utilizing a suite of NVIDIA AI and Omniverse technologies. Top robotics developers come together, the new robotic workforce in America. In order to bridge skills gaps, increase worker productivity, and improve safety across industries, robotics businesses are utilizing NVIDIA's 3-computer architecture to develop and implement sophisticated fleets of robots. To speed up the development of next-generation humanoid robotics, Figure and NVIDIA formed a partnership. Figure is quickly creating the most sophisticated, large-scale humanoid fleet in the world, with the ability to perform everything from domestic tasks to industrial assistance, by utilizing NVIDIA's accelerated processing to create its Helix Vision Language Action Model and the Isaac platform for training and simulation. Through millions of reinforcement learning scenarios, Digit, the general-purpose humanoid from Agility Robotics, uses the NVIDIA Isaac Lab framework to improve whole-body control. This speeds up improvements to its skill sets, such as step recovery from environmental disturbances, which are frequently required in highly dynamic environments like manufacturing and logistics facilities. The NVIDIA Jetson AGX Thor module powers Digit, allowing for autonomous decision-making, real-time sensing, and navigation. The development of Amazon's mobile robots and various manipulation systems, which are powered by the NVIDIA Jetson platform, is being shortened from years to months by Amazon Robotics through the use of Omniverse libraries and frameworks. Amazon's recently announced BlueJ multi-arm manipulator for choosing, stowing, and consolidating went from concept to production in little over a year, all thanks to simulation training. Using NVIDIA Cosmos TM World Foundation models to generate training datasets and Isaac Lab for locomotion and dexterous manipulation task training, Skilled AI is developing a general-purpose robotics foundation model that encompasses legged, wheeled, and humanoid robots. Using NVIDIA Isaac SimTM for software-in-the-loop validation and synthetic data creation, and Isaac Lab for reinforcement learning, Field AI is teaching cross-embodied robot brains for monitoring and inspection in oil and gas and construction contexts. NVIDIA offers cutting-edge solutions and collaborates with top cloud service providers to give widespread access to the potent AI and simulation infrastructure required to boost American manufacturing. Leading companies in the sector, such as Diligent Robotics, EndoQuest Robotics, Hitachi Rail, Joby Aviation, Maven, and SETI Institute, are implementing NVIDIA IGX Thor, an enterprise-ready platform powered by NVIDIA Blackwell that is intended to power the next generation of industrial and medical edge AI applications. Microsoft will soon provide these GPUs in the Microsoft Azure public cloud, as well as at the edge with Azure Local Distributed Infrastructure, while Google Cloud announced that its new G4 instances powered on NVIDIA RTX PRO 6000 Blackwell Server Edition GPUs are now available. Through its partnership with Uber, NVIDIA prepares the world for robotaxis in order to facilitate global expansion. The reference computing and sensor architecture, NVIDIA Drive AGX Hyperion 10 makes any car Level 4 ready, allowing developers and OEMs to create fleets that are safe, scalable, and AI-defined. Drive AGX Hyperion-ready cars will power Uber's global ride-hailing network, which will combine human passengers and robot drivers. While Aurora, Volvo Autonomous Solutions, and Wabi expand Level 4 autonomy to long-haul freight, Stellantis Lucid and Mercedes-Benz are working together to develop Level 4-ready autonomous vehicles compatible with Drive AGX Hyperion 10 for passenger mobility. Starting in 2027, Uber plans to scale its worldwide autonomous fleet with a goal of 100,000 vehicles, backed by a collaborative AI data factory constructed on the NVIDIA Cosmos platform. Avrede, May Mobility, Momenta, Neuro, Pony.ai, Wave, and WeRide are all part of the expanding Level 4 ecosystem that NVIDIA and Uber continue to support. The first method in the industry to assess and certify physical AI safety for robotics and driverless cars is NVIDIA's Halos certified program. Using the company's next-generation robotaxi and autonomous delivery fleets, the new NVIDIA Drive AGX Hyperion 10 autonomous vehicle AV development platform, and NVIDIA Drive ATM AV software specifically designed for L4 autonomy, NVIDIA today announced its partnership with Uber to scale the largest Level 4 ready mobility network in the world. Over time, starting in 2027, NVIDIA can help Uber scale its worldwide autonomous fleet to 100,000 vehicles by facilitating faster growth throughout the Level 4 ecosystem. Using NVIDIA Drive, these cars will be created in partnership with NVIDIA and other Uber ecosystem partners. In order to gather and process the data required for the development of autonomous vehicles, NVIDIA and Uber are also collaborating to create a data factory, which will be expedited by the NVIDIA Cosmos TM World Foundation Model Development Platform. Any car may be made L4 ready with the reference production computer and sensor set architecture known as NVIDIA Drive AGX Hyperion 10. In order to provide a uniform basis for safe, scalable, and AI-defined mobility, it allows automakers to construct cars, trucks, and vans with verified hardware and sensors that can host any compatible autonomous driving software. Uber is integrating human and robot drivers into a single operating network, creating a ride-hailing service that runs on both vehicles. This network allows Uber to effortlessly connect today's human-driven mobility with tomorrow's autonomous fleets, thanks to NVIDIA Drive AGX Hyperion-ready cars and the surrounding AI ecosystem. According to NVIDIA founder and CEO Jensen Huang, Robotaxis represents the start of a worldwide revolution in mobility that will make transportation safer, cleaner, and more effective. Together with Uber, we're developing a framework that will enable the industry as a whole to implement large-scale autonomous fleets using NVIDIA AI technology. Science fiction is quickly giving way to actual life. According to Uber CEO Dara Khosrowshahi, NVIDIA is the foundation of the AI age and is now fully utilizing that innovation to unleash L4 autonomy at massive scale while making it easier for NVIDIA-powered AVs to be deployed on Uber. We're excited to work with NVIDIA to help realize the goal of autonomous mobility, which will improve our cities. The growth of the NVIDIA Drive Level 4 ecosystem. To introduce Level 4 fleets with NVIDIA AI behind the wheel, top international automakers, robo-taxi firms, and Tier 1 suppliers are already collaborating with NVIDIA and Uber. Stellantis is creating AV-ready platforms that are especially tailored to satisfy robo-taxi specifications and provide Level 4 capabilities. These platforms will further increase connectivity with Uber's global mobility ecosystem by integrating NVIDIA's full-stack AI technologies. Additionally, Foxconn and Stellantis are working together on systems and hardware integration. In addition to employing full-stack NVIDIA AV software on the Drive Hyperion platform for its next US models, Lucid is developing Level 4 autonomous capabilities for its next-generation passenger cars. Mercedes-Benz is testing upcoming partnerships with top industry players using Drive AGX Hyperion and its in-house operating system, MB.OS. Continuing its innovative heritage, the new S-Class provides a remarkable Level 4 chauffeured experience that blends elegance, safety, and advanced autonomy. Avride, May Mobility, Momenta, Neuro, Pony.ai, Wave, and WeRide are just a few of the global Level 4 ecosystem partners that NVIDIA and Uber will continue to assist and expedite as they develop their software stacks on the NVIDIA Drive Level 4 platform. Waabi, Volvo Autonomous Solutions, and Aurora are creating Level 4 autonomous trucks in the trucking industry using the NVIDIA Drive technology. Their next-generation systems, which are based on NVIDIA Drive AGX Thor, will speed up Volvo's planned L4 fleet and expand the application of NVIDIA AI infrastructure from long-haul freight to passenger mobility. NVIDIA Drive AGX Hyperion 10, the standard platform for automobiles prepared for L4. The NVIDIA Drive AGX Thor system on a chip, the safety-certified NVIDIA Drive OSTM operating system, and other components are included in the NVIDIA Drive AGX Hyperion 10 production platform. 14 HD cameras, 9 radars, 1 LiDAR, 12 ultrasonics, and a qualified board design are all part of a fully qualified multimodal sensor suite. Because Drive AGX Hyperion 10 is modular and adaptable, AV developers and manufacturers can customize it to meet their specific needs. The platform provides a pre-qualified sensor suite architecture, which speeds up development, reduces expenses, and provides clients with a head start by granting them access to NVIDIA's extensive development experience and investments in automotive engineering and safety. Two powerful Drive AGX Thor in-vehicle platforms built on the NVIDIA Blackwell architecture form the basis of Drive AGX Hyperion 10. Drive AGX Thor, which combines various 360-degree sensor inputs and is optimized for transformer, vision language action, VLA models, and generative AI workloads, can each deliver over 2,000 FP4 teraflops, 1,000 TOPS of INT8 of real-time compute. This allows for safe Level 4 autonomous driving, which is supported by cybersecurity standards and industry-leading safety certifications. In addition, Drive AGX's scalability and compatibility with existing AV software lets companies seamlessly integrate and deploy future upgrades from the platform across robotaxi and autonomous mobility fleets via over-the-air updates. Autonomy is transformed by generative AI and foundation models. Large language models, generative AI, and foundation AI models that have been trained on trillions of actual and artificial driving miles are all used in NVIDIA's autonomous driving strategy. These sophisticated models enable self-driving systems to respond and reason like humans in extremely complex urban driving scenarios. To enable human-level understanding in AVs, new reasoning VLA models integrate action generation, natural language reasoning, and visual understanding. The AV can evaluate complex and uncertain real-world situations, like abrupt changes in traffic flow, unstructured intersections, and erratic human behavior, in real time by executing reasoning VLA models within the car. In order to test and validate these models, Fortelix, the leader of the AV toolchain, is working with NVIDIA to integrate its Fortify physical AI toolchain with NVIDIA Drive. NVIDIA is also making available the largest multimodal AV dataset in the world, which will help the industry create and assess these massive models for autonomous driving. The dataset is intended to support the development, post-training, and validation of foundation models for autonomous driving and consists of 1,700 hours of real-world camera, radar, and LiDAR data from 25 different nations. The NVIDIA Halos technology creates a comprehensive framework to enable safe, scalable autonomous mobility by delivering cutting-edge safety safeguards from the cloud to the vehicle. With a focus on AI safety and cybersecurity in robotics and automobiles, the NVIDIA Halos AI Systems Inspection Lab conducts independent assessments and manages the recently launched Halos Certified program, assisting in making sure that systems and products fulfill strict requirements for reliable physical AI deployments. The NVIDIA Halos AI System Inspection Lab is the first in the industry to receive accreditation from the ANSI Accreditation Board, and its first members include companies like Amovio, Bosch, Neuro, and Wavy. Accelerating the safe, widespread implementation of Level 4 automatic driving and other AI-powered devices is the lab's goal. On Tuesday, NVIDIA revealed that pharmaceutical company Eli Lilly is constructing an AI supercomputer that will use over 1,000 Blackwell Ultra GPUs. According to the chip giant, this will facilitate industrial-scale advances in molecular design, genomics, and customized medicine while also reducing the time it takes to find new drugs. The system, which NVIDIA calls an AI factory, was unveiled at the company's GTC in Washington, D.C., and would train frontier and biomedical foundation models for the creation of novel medications. Lilly's TuneLab AI platform, which will also run NVIDIA's Clara Open Foundation models for healthcare, will make some of those models available to other businesses, according to NVIDIA. According to a statement from Thomas Fuchs, Chief AI Officer of Lilly, "Our foundation models are spawning new possibilities for our chemists, helping them uncover new motifs and configurations of atoms that were out of reach with traditional methods." He continued by saying that AI provides the tools to speed up the development and delivery of better, more individualized and targeted medications. According to NVIDIA, Lilly will develop its AI system on the NVIDIA DGX SuperPod, which will let Lilly to run extensive language models that can reduce the time required to process medical images and write up clinical studies. The agreement with NVIDIA is a component of Lilly's $50 billion endeavor to expand its R&D and manufacturing footprint in the United States, which also includes a projected $4.5 billion lab in Indiana and 4 additional facilities. According to NVIDIA, Lilly may also utilize its NVIDIA Isaac and Isaac Sim offering to create AI agents using NVIDIA's NeMo software, which can run around the clock and conduct trials to create new possible therapies and roll out robots as part of its production pipeline. The collaboration demonstrates the depth of NVIDIA's presence in a number of sectors, including big tech cloud platforms, automakers, and more. The news follows a slew of similar GPU agreements and comes just weeks before the AI leader is scheduled to release its third-quarter earnings. However, NVIDIA is also facing risks from its own clients, like Amazon and Google, which utilize both NVIDIA chips and their own AI processors, as well as growing competition from companies like AMD. With its own AI accelerators, Qualcomm entered the AI data center competition on Monday, extending NVIDIA's competitive edge, according to the firm. But because of its enormous first-mover advantage and CUDA software, which enables developers to extract their acquired processing power from its chips, the chipmaker is still mainly projected to maintain its leading position in the AI battle. According to a Bloomberg report on Tuesday, NVIDIA CEO Jensen Huang is scheduled to sign new supply agreements for AI chips with significant South Korean companies while in the nation this week. According to reports, the deals will involve collaborations with Samsung Electronics Co., Hyundai Motor Group, and SK Group, assisting NVIDIA in growing in a crucial market as it encounters more limitations in China because ongoing trade tensions between the US and China. These agreements would provide Korean businesses with consistent access to the graphics processing units needed to train and run AI models. Huang wants to increase NVIDIA's footprint in South Korea, which is vital to the world's memory chip manufacturing and aspires to be a significant center for AI computing. One of the intended beneficiaries of NVIDIA processors, SK Group, is building an AI data center in South Korea worth 7 trillion won, $4.9 billion. Chipmaker SK Hynix Inc. is one of the conglomerate's affiliates. The announcements are anticipated prior to Huang's attendance at Friday's APEC CEO Summit in Gyeongju. President Donald Trump said he will meet with Huang on the executive's Asia tour, while the NVIDIA CEO is in Washington on Tuesday for a conference. Don't forget to share your thoughts and experiences in the comments below. Your input helps create a more knowledgeable community where we can all learn and grow together in the world of investing. Stay up to date with the latest market trends, insights, and key updates by subscribing to Investing Tutorial. We're here to help you make smarter investment decisions and stay ahead of the curve.